Hey lads, I'm going to a match today, but we may as well keep going on this, okay? So if you want to take down your homework there, I'll give you a second. Page 179 and page 180, question 1 and 2. And the optional homework, have a go at question 4 if you have the time. The lesson aims, well today I'm going to revise the permutations. I know Richard, you're out, so hopefully you're back in now. So just listen carefully, and there should be no problems with revising the permutations, revising the probability, revising factorial, and then I'm going to get on to looking at the Bernoulli trials. Okay, so just take down the homework, please. Okay, so looking back over permutations. Permutations are how many ways a list of objects can be arranged. When I say objects, it can be like things, like people, numbers. So our list of objects here is A, B, C, and D. So how many different ways can we list out A, B, C, and D? So one example, well, I could list it out, obviously A, B, C, and D. I could list it B, C, A, D, etc., etc., etc. So if we're asked how many different ways I can list out the objects, basically we'll draw 4 boxes. And if they don't give us any stipulations, so if they don't say to us, we can't repeat the letter, then we just presume we can repeat the letter. So if I was asked how many different ways I could list these letters, well, obviously my first letter, how many choices have I? I could choose an A, a B, a C, or a D, so I have 4 choices. Now, if I'm allowed repeat the letters, how many choices have I for my second letter? Again, I have A, B, C, and D. So I still have a choice of 4. How many different choices have I for my third letter? Again, A, B, C, and D. And my fourth, A, B, C, and D. And all I do is multiply my 4 boxes. Okay? Sometimes they give stipulations, so sometimes they'll say you can't repeat any of the letters. So let's have a look at that. So again, we're going to arrange it, see how many different arrangements we can make from A, B, C, and D. So, but we can't repeat the letters this time. So let's have a look. How many choices have I here for my first letter? I have A, B, C, and D, so I have 4. Now I can't repeat the letter, so whatever letter has gone in here, whether it's A, B, C, or D, I can't use it here. So basically I'm after using one of these letters, whether it's D, or C, or B, or A. So really I've only 3 choices left for my second letter. Now I'm after putting in a letter here, and I'm after putting in a letter here. So how many have I left? How many choices? 2. And then, of course, if I'm after putting in 3 letters here, well, then I've only 1 choice left. Okay? So again, we know this, but I'm just running over it. Sometimes they might give us a stipulation. They might say the letter A has to come first. So let's look at that. Well, if the letter A has to come first, how many choices have I for my first letter here? 1. It has to be A. So if A is used, then how many choices have I for my second letter? 3. And again, if A is used up here, and another one of these letters are used here, I have 2 choices left for my third box, and 1 choice left for my last box. Okay? So quickly looking at factorial. So for anyone who was missing the last day, this is what it looks like, basically an exclamation mark. And all it means is, we multiply, let's say factorial 4 is simply 4 multiplied by 3, multiplied by 2, multiplied by 1. Okay. We can type in 4 factorial into our calculator, press equals, and it saves us the trouble of putting in 4 multiplied by 3, multiplied by 2, multiplied by 1. Now granted, that's not very hard to put in a calculator, nor would this. But if we were asked to find the number of ways we can list 100 objects, well, that might be a lot difficult, or a lot longer of a process to do in our calculator if we had to write in 100 multiplied by 99 multiplied by 98, blah blah blah. So again, a quick way to do it is just typing in 100 factorial into our calculator, pressing the equal sign, and that'll do it for us. The only thing we have to be careful here is 4 multiplied by 3 multiplied by 2 technically is not 4 factorial, even though it doesn't really make much difference because it's a multiply by 1. Same as that's not factorial. Okay, so just remember it has to go all the way down to 1. Okay, so looking back over our probability, remember I said and in probability means multiply. Okay, as soon as you hear and, you think I multiply. Or means add, so as soon as you hear or, you think I must add. Remember, probability goes between 0 and 1, 1 being certain and 0 being not a hope in hell of happening. Okay? And our formula basically is the probability of an event happening is the number of successful outcomes over the number of possible outcomes. So let's have a look. Let's say I have a die. And obviously on a die there's 6 sides, 1, 2, 3, 4, 5 and 6. Now what's the probability of me rolling a 6? Well, let's look down to our formula. Well, there's one successful outcome and that's the 6. So how many 6s are on a die? 1. So I have one number of successful outcomes, which is the 6 I want to roll. And the number of possible outcomes, well, it's possible to roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So the number of possible outcomes goes underneath. So the chances of me rolling a 6 on a die or on a fair die is 1/6. Okay? And we can change that into a decimal to ensure it's between 0 and 1. Okay? Right, moving on. If I asked you the question, what's the probability of rolling a 6 or a 5? Or a 5. Let's look. Probability of rolling a 6, well, we said it already, 1 over 6. The probability of rolling a 5, there's 1 5 here, so again it's 1 over 6. And have a look here, I said the probability of rolling a 6 or a 5, so or 5. We add the 2 and we get 2 over 6. And that makes perfect sense because if I look at it a different way, the probability of rolling a 6 or a 5, well, that means I can roll any of these two, which is 2 successful outcomes out of the total of 6 outcomes. Okay, so I think that makes perfect sense, or should anyway. Okay. Okay, the last thing we're going to do today, is we're going to look at, I suppose, the new topic, because everything else was you knew already or should have known already. So we're going to look at the Bernoulli trial, and basically it's combining 2 events. Okay. Just remember, and means multiply. So for instance, the 2 events here, I have a black die and a red die, and we're going to look at the probability of rolling, I suppose, numbers between the 2 die. Okay. So first of all, I'm just asking you, how many different combinations is there possible when rolling these 2 die? Well, I could roll a 1 and a 1, could roll a 2 and a 1, I could roll a 2 and a 2, could roll a 3 and a 4. Let's see how many combinations there is possible. Well, I have 6 choices or 6 options when rolling my first black die. I can roll a 1, a 2, a 3, 4, 5 or a 6. So 6 choices here. And on my red die I have the exact same. I can roll a 1, a 2, a 3, a 4, a 5 or a 6. Okay. And to find out how many options there is in total, I can multiply the 2 and I get 36. Okay? So there's 36 different combinations between rolling 2 dice. Okay. What if I said then, what's the probability of rolling a 2 on the black and a 3 on the red? And again, a 2 on the black, so that's 1 chance out of 6, and on the red I had 1 chance out of 6 again. I multiply the two because remember what I said, what's the chances of me rolling something here and something here. So if we multiply the two, I get 1 chance out of 36. And again, we can change that to a decimal. Okay. Sometimes, lads, what they ask in the exam is if the scores of the two dice are added together. So if I roll a 1 the first time and a 3 the second time, the combined total is 4. Okay? So what they might ask is, what's the probability when you roll the two die that you'll get a combined number of less than 6, for example? So, in a question like that, the best thing to do is draw out a sample space diagram. So if you look, I have my black die here going from 1 to 6. I have my red die here going from 1 to 6. And basically, all these numbers in between is the combined total score. So for instance, if I roll a 1 on the black die and a 1 on the red die, I get a total of 2. If I roll a 4 on the black die and a 4 on the red die, I get a total of 8. Now that's going to help me big time when I'm asked the question, find the probability of rolling, as I said, less than a 6. Well, if we look here, like we found out earlier on, 6 multiplied by 6 is 36. So there's 36 possible outcomes. So again, remember back to our probability a few days ago, total number of outcomes and number of successful outcomes go on top. So we're looking at the probability of rolling less than a 6. Okay? So let's underline anything here that's less than a 6. Okay? Not including 6, less than a 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chances of rolling less than a 6 out of a combined total of 36. Again, if we type that into our calculators and press equals, we can change it to a decimal. Okay? Hey guys, that's it for today. You should have a bit of time left in class, so if you want to get started on your homework, by all means, may I suggest starting on the optional homework. Okay? I'll see you tomorrow, so good luck, lads.